Okay, friends, this is the fourth episode of the series simulation. In today's video, we are going to discuss how to simulate a discrete distribution. So, first of all, we need to understand the basic nature of a discrete distribution, where the discreteness comes from the fact that the number of outcomes are countable or discrete in nature, and for each outcome, there is a particular probability, and sum of the probabilities is equal to 1. So for example, if you monitor, this is an example only, if you just monitor the number of accidents happening in a particular section of road, then you may find that these these outcomes are there. That means it can be 0 accidents, or just 1 accident, 2 accidents, 3 accidents, and 4 accidents, and each one having a particular probability, and the sum of the probabilities are equal to 1. So earlier in the previous part of the presentation, we discussed about continuous distribution. All these distributions are continuous in nature, and using specific Excel functions, we can actually formulate the inverse functions of these particular distributions. But in case of discrete distribution, that is not going to happen. So discrete distribution is like this. If you plot the outcomes here and the probability here, these are the outcomes and this is the probability. So for each outcome there will be a particular probability value. Remember, I am not drawing this one, which is just a random figure. So for each x value you have a px value, probability value, but you cannot join these points using a line. Whereas for a continuous distribution, the entire x-axis is feasible. That means if any value, the x can take any value continuously, that means any real number, and then for each x there is a particular px. That means what? The line, the px line, is a continuous line. So this is the basic difference between the nature of distribution for a continuous and discrete distribution. This much you need to learn here. Nothing more than this is required, because we are not studying pure statistics here. We are trying to implement simulation models from entirely from the management science point of view. So just this much of knowledge is essential and required. Nothing more is required. So fine, then what, how to simulate is the main question. So you have seen in the last slide that this much is given. This portion of the table is already given. That means the number of outcomes and their probabilities. So now in order to simulate, you need to extend this table. That means you have to add two columns. First of all, the cumulative probability column, and then the lower bound. So how to write the cumulative probability? The first value will be the probability itself. From the next value onwards, just add the value of the probability cumulatively. That means this is 0.4, so add 0.4 to 0.55 to get 0.95. Then 0.02 plus 0.95 gives you 0.97. Then again 0.02 plus 0.97 gives you 0.99. And then finally 0.01 plus 0.99 gives you 1. So in case of any discrete distribution, the cumulative probability column will show you 1 in the last row. Okay. Now about the lower bound, how to construct the lower bound? It is simply just cumulative probability offset by one row. That means you will start with 0 and then write the cumulative probability here. So this is equal to this is equal to this, and so on. So therefore the last value will not be equal to 1, it will be equal to the previous cumulative probability value. Okay, so this is how the table should be extended first of all. And then for each replication we will generate a random number. So how to generate a random number, you have already learned. You are going to use the rand function. So After that, you will use the VLOOKUP function in order to simulate. So for that VLOOKUP function, the first argument is the random number. Actually, if you try to type the VLOOKUP function in Excel, the first argument is the lookup value. Lookup value. So that lookup value in our case is the random number. Then the next argument is table 1. What is table 1? Table 1 is this portion of the table. That means this lower bound and number of accident. Please note very carefully that you have to define table 1 in proper manner. That means you should not include the headings also. You should only include the numerical part of the table and only these two columns, right? That will be your table 1. And what is the last argument? Last argument is the column number, which is always equal to 2. Why it is equal to 2? Because you are trying to pull the number of accident, or actually the outcome, these things. So VLOOKUP function will return you these things. So in table 1, this is column number 2, and therefore always the reference is column number 2. So if you have understood this much, you are ready to simulate in Excel. So first of all, let us define the problem. So this is our problem definition. There is a company and there is a product, and the selling price of that product is $45, which is constant. And there are three types of costs: procurement cost, labor cost, and transportation cost. For procurement cost, the distribution is given, and for labor and transportation cost also, the distribution is also given. And these three are discrete distribution. So therefore, procurement cost can take three types of values: 10, 11, 12. The probabilities are given. If you add this probability, you will get 1. Similarly, labor cost can take 4 values and the probability are given here, and the sum is equal to 1. Similarly, transportation cost can take 2 values. For these, probabilities are given and the sum is again equal to 1. So please don't ask these questions like what will happen if the value is 10.5 or 11.2, something like that. This is not going to happen because this is a discrete distribution. For discrete distribution, the number of outcomes, these are fixed. No any other value, none other than these can be obtained. So procurement cost, only three levels are possible: $10, $11, and $12. Similarly, labor cost can take only these four values: 20, 22, 24, and 25. Okay, so this is the data given to you. And what are the questions asked? There are two questions to be answered. First of all, the average profit per unit, and secondly, the probability of having a profit per unit less than $5. So this is the problem, and you have understood the theory also. And so let us now, don't wasting any time, uh, move on to the Excel spreadsheet. So this is our Excel sheet. As we can understand, we have to extend the tables. You see, the probabilities are exactly same that we have defined here. These three tables are basically copied here, and so we have to extend them by using the cumulative probability. Cumulative probability, how to calculate that? We have already learned. The first one is the same, and the second one is this plus this. Just try to understand. This plus the previous one, and then copy this. And so you can copy this here also, and you have to extend this because there are four categories. And you can copy this here also, and then we have to add the lower bound column. How to do that? First one is 0, and from the second one onward, you just have to refer this cumulative probability of previous value. So this, just copy this, So our tables are complete. So what to do with this table? We have to construct a simulation model. So remember, if you have watched the previous video, the style we adopted in the last video was that we will first replicate one replication. That means we'll first build the model for just one replication, and then by using the data table option we'll simulate. So let us first develop the single replication. That means the first replication here. So this is the selling price. This is given to you. How much? $45 per unit. Then for calculating profit, you need to have the procurement cost, labor cost, and transportation cost, right? But this is the first replication of the simulation. So these are the random variates. So if these words are alien to you, please refer to the previous videos. It is very important. See, I always tell you to watch the previous videos because each video is a built up process based on the previous few videos. So if you don't watch them, you will not fully understand the process, what is going on here. So it is absolutely essential to watch the previous videos. So first of all, you have to write the random numbers, generate the random numbers here, and based on the random numbers you have to use the VLOOKUP function in order to generate this random variate. So how to use the VLOOKUP function we have discussed in the slide. This is your formula. So start with VLOOKUP. What is the lookup value? Lookup value is your random number. Then what is your table array? Table array was this much. Then column index number. What is the column index number? We have already told you it is always equal to 2. So 2. So this is your random variate with respect to procurement cost. Similarly for labor cost, use VLOOKUP. Lookup value is this random number. Table array is this table, and column index number is always 2. Again for transportation cost, VLOOKUP. Lookup value is always the random number. Then the table array is this one, and column index number is 2. See, if you are formulating in this way, your column input number cannot be anything else. It is always equal to 2 because this procurement cost, labor cost, transportation cost, all are coming in the second column. Okay. So if this is complete, then you can calculate profit per unit very easily. That is how much? Selling price minus the sum of these three costs. Okay. So this is your profit per unit. Now, in the last video, if you have remembered, the replication was built in the left side of the worksheet, and then in the right side we had our data table option which generated the 1000 simulations. But in this case, we'll just use this reference only and write the replications here. So for that, write your replication number here from 1 2 3 and so on. I will use 1000 replications only because I am doing it for the academic purpose. You are free to extend this up to 5000 or maybe 10,000 or even more. I am doing it for 1000 replications, right? So now what is our data table? This is our data table. So entirely select this one, then go to data, what type analysis, data table. Row input cell will be kept blank, and in column input cell you will be entering a cell reference having 0 and nothing entered. That means blank cell, suppose F7 or F8, any cell that has nothing written there. So say it is F8 and then click on OK. So these are your replications. So 1000 replications, 1000 profit per unit figures are there. So now you are ready to answer the two questions. First one is the average profit. How to calculate? Very simply, average over this range. This is your average. And for the probability, first of all, we will calculate the count of profit being less than $5. How to do that? You have learned to use the countif function, countif over this range, and then what? Less than and 5. And what is the probability? Probability is this much divided by 1000, right? So these things like data table, countif function, rand function, and few more things. These things are already explained in the last video, so I am not explaining this here in this video. So if you have watched the last video, you will definitely understand how I am building these data tables and using these countif functions, how to calculate the probability. All these things are actually explained in very details in the last video, so please watch that. So that's it. In this way you can calculate the average profit and probability of profit being less than 5 very easily. You see here, as you refresh this probability is changing quite a bit. So now it is say we express this in terms of percentage. So now it is 8.5%. Next time it is 8%. Next time it is 8.6%. So what I am doing is I am using the F9 key. So if you use the F9 key of your keyboard, the sheet will be refreshed every time, and you see these values will be changing. Like sometimes it is 6.8, then 8.2, 7.8%, 8.2%, 8.6%, 8.3%, 7.8%, and like that. So if you're wondering that's why so much variation is occurring, it will occur because you have used only 1000 replications, which is not sufficient. To get a particular level of uniformity or level of the probability, you need to at least use 5000 to 10,000 replications. Then you will see this probability value may be actually freezing towards a particular mean value, like for example 7% or 7.5%, whatever, I don't know whatever it is. So it can be your homework also. Just replicate this worksheet here as I have done here. Do it in your home, and then instead of using this 1000 replications, just extend this table up to 10,000 or maybe more than that also, 50,000, 1 lakh, and then you try to see what is the probability figure that you are getting. Using F9 in your keyboard, try to refresh that worksheet and see if the probability values are actually varying too much. And my guess is it will be varying within a very little range, so it will be almost constant. So that's it. That's how we will develop any simulation model related to a discrete distribution like I have developed here. So hope you have understood the problem and the development of the worksheet, and that's it for now, and let us meet in the next video next week, and thanks for watching this video.